Very good morning to everyone. This is Orpin Avait. Let's see about file systems and input-output management and storage. The presentation explores the fundamental concepts of file systems, input-output management, and storage in operating systems. We will cover the types of file systems, the methods of accessing files, and how disk structures relate to the systems. Let's go start with the file systems. So, what's the role and definition in it? A file system is a method and a data structure that an operating system uses to manage files on a storage device. It organizes data into files, which can include metadata such as file name, permissions, and size. The role of a file system is to provide efficient data access, storage management, and to ensure data integrity and security. There are types of files storage, which is FAT32 and NTFS, ext30 and ext4, APFS and HFS plus. File systems vary by platform and purposes. FAT32 and NTFS are common in Windows, offering features like journalizing and security. ext3 and ext4 are popular in Linux due to their robustness, while APFS and HFS Plus are used in macOS, focusing on efficiency and encryption. So, comparing the major file systems. So, the major file system involves accessing attributes such as performance, supported sizes, and access methods, as well as a degree of complexity and robustness. For instance, NTFS supports larger files and more complex permissions compared to FAT32, while ext4 offers journalizing for data recovery. So each type holds a unique value and use in it. So once we have stored the files, accessing is the main thing we have to do. So let's see about file access. So there are many types of access. One is sequential access, and another one is direct access, and another is indexed access. So let's read about these three. So in sequential access, data is read in a linear fashion from start to end. It is optimal for streaming data but inefficient for random retrieval. This method is commonly used in tape drivers and certain data processing systems where order is preserved. So in direct access allows the retrieval of data from any location without needing to read through other data first. In method is common in hard drives and SSDs, facilitating fast performance for applications requiring quick access to specific files. In indexed access, it uses an index to map file locations. So once it is the file locations are mapped, allowing for faster researches which is in a file system. This method is used in databases and systems requiring quick lookups, as it can significantly reduce retrieval times. So that's where index access comes in handy. So let's see how about disk structure. So there are three components in it, which is tracks, sectors, and cylinders. So tracks are concentric circles on a disk surface where data is recorded. So each track is divided into sectors, typically containing 512 bytes or more. The cylinder consists of all the tracks that align vertically across the plateaus of a hard drive. It enables efficient data access strategies in it. So in clusters and physical structure, clusters are the smallest unit of disk space allocation, so consisting one of the more consecutive sectors. This structure affects how files are stored and retrieved. So in influencing the disk performance, the physical structure of a disk refers to its plateaus, read-write heads, and the spinning mechanism that enables the data access. So in disk scheduling algorithms, The rescheduling algorithms manage how requests for data are processed on disk drivers. So, in common algorithms include first come first served and shortest seek time first, which is SSTF, and scan, which optimize disk access patterns to reduce wait times and enhance performance. So the performance graphs help visualize their efficiency actually. So in input output management, the definition and importance of in input output management is the subsystem responsible for controlling input and output devices, coordinating data transfers between the devices and the operating system. Its importance lies in ensuring efficient operation of devices, optimizing performance, and providing a seamless interface for users and applications. So, the examples of input output devices. The common input devices include keyboard, mice, and scanners, which allows users to interact with the computer. So, output devices such as monitors, printers, and speakers enable the system to convey information back to the user. So, each device has a specific role in the overall computing experience. So the role of the device drivers in it. So the device drivers acts as intermediates between the operating system and hardware devices, facilitating the communication and control both. They ensure that the OS can send and receive data to or from devices efficiently. Handling unique signals, interpretations are necessary and commands for operation. So, in which is in data management, so buffering versus pooling are there. So buffering temporarily stores the data being transferred between devices and improving performance by allowing devices to operate at their own rates. So pooling on the other hand involves queuing data for processing, allowing the system to manage multiple outputs like printing documents sequentially without using intervention actually. So there are some disk formatting techniques. So disk formatting techniques prepares a storage device for usage by creating a file system that organizes data. So the low level formatting initializes the disk surface while high level formatting sets up for the file system structure, ensuring proper data management and storage capabilities. So in conclusion, I'll summarize. So, understanding file systems, input output management, and disk storage techniques is essential for optimizing system performance and data integrity. These components work together to ensure efficient data handling, secure storage, and swift access for users and applications. So, thank you for listening to it. So, if you have any questions, you can truly ask.